All right, I guess we'll call this part 2 of our fuel pump, right? Because we already did our part 1 video. So what I wanted to do before we put this pump in is show you guys one thing that I was not able to show because I had the car at a no start at one point in time, and that was the pressure drops on a snap. And then this is a cold start too, so we'll actually get an opportunity to see what this looks like on a crank. Go ahead and crank that, Dave. See how slow that pressure built up? And you saw it, I mean, it was actually able to start, you know, at 20 pounds of pressure. And I did make that statement before that this system should start where we were, but the reason it wasn't was because it was so vapor locked. So we're at 42 PSI, 40 PSI. That's pretty much, my guess is that's pretty close to normal for an idle pressure on this car. And I'm going to take the vacuum hose off the regulator again. A very slight increase, not that, you know, 6 to 10 in that range is what we want to have. Right now we should be more about 54, 52 PSI. And then here's the key would be when you do these kind of pressure checks, take the vacuum hose off the regulator and then snap the throttle. Never want to see a drop in pressure during that event. I mean, a momentary little hiccup is okay, but we never want to see that. So that again can be regulator, fuel filter, fuel pump. We've addressed all of that already. We know we need a pump, and that was just one aspect of my last video I was not able to show. If this vacuum hose was connected, what this would look like is when I snap it, that pressure would rise because we are losing vacuum to the regulator, and on a good system, that's what we'll see. So we'll revisit this test one more time after we get the pump in. And we'll redo our RPM and we'll redo our pressure checks and amperage measurements too. One more time, this is with the vacuum hose plugged in. It won't be any different because this regulator's never opening. We're never reaching the regulated pressure, so it's going to do the same thing. Never want to see that. That is always a weak fuel pump. Well, I don't want to say always a weak fuel pump. That would always be a fuel delivery problem when you see that. Okay, so we finished the car. This is the crew that put my fuel pump in for me. They wanted to be on film. I said these are my star pupils. I have another guy behind me who's also one that's not in the film here. I have a bunch of star pupils this term. Oh, there he is right there. Although the guy that just came in the picture wasn't really helping too much on the job, but we'll still give you some props anyway. So it's Dana and Nikki and Carmen and Zach and Dave. How was that? That wasn't bad for only knowing you guys for like 3 weeks. So nice job. These are some of my guys here at Rosedale Tech. So props to them. Back on the car, I'll show you the result of this new fuel pump. All right, we have the car running already here, guys, and I'll shut it off and let you see how fast this builds pressure. But what we can see right away is a big difference in our idle pressure. And I think maybe the first test I'll show you guys would be the vacuum hose off of the regulator. Dana, can you pull the vacuum hose off of the fuel pressure regulator for me so we can watch the pressure gauge?
Sure.
That's okay. Nikki, Dana, whatever. Thank you. All right. Look at the gauge. What happened? We went from, let's put the line back on. Let's watch it again. So what's that number? About 48, 47. So 47 PSI. Take the vacuum hose off. And we went to, looks like about 57, huh? So there's about a 10 PSI difference from idle to, which this would be just so you guys understand, this is a simulated wide open throttle pressure. Wide open throttle, there is no vacuum. So when you take the vacuum hose off a regulator, this is a way that you can simulate your key on, engine off, or wide open throttle pressure. Now granted, the injectors aren't opening much, so it's not really a volume test, but it is a good test. And to match what we did before, we actually did our snap throttle test with that vacuum hose off. So let's leave that off. Watch the pressure gauge. We'll do the same thing we did before. Yes, please, can you do that, Dave? Notice the gauge didn't drop, although that was kind of a little wussy rev there, Dave. Give me a rev, a good one. Give me a, there you go. Now I revved it even more than that, so here's what I want you to do. As fast as you can, let me finish. As fast as you can to wide open, hold it till we hit the rev limiter, then let off. That was better. Do you see that little bit of a blip in there? That's okay. I don't mind that, but you see the difference in what we had before. We were around 40 and it was dropping to 35, so we were low from the get-go. You never want to see that kind of a drop on an XL. Go ahead, do it again. A little bit of a blip, no problem there at all. And so this test, what we call this, is a volume test. What we're doing is we're opening the injectors up, we're making sure that the pump can keep pressure when the injectors are opening, and this is a much better test than just looking at fuel pressure, say static. Okay. Yeah, the reason I had the vacuum line off was that was what we did last time, just to simulate the yes. Okay. And now we'll do the same test with the vacuum line on this time, so you guys understand why I like to leave it off. Go ahead, do it now. And I know, Dave, you probably can't see the pressure gauge, but what was happening, you got it now, Dana, so Dave can see it? Yep. What's happening here is the pressure gauge is rising. You just hit the rev limiter, that was all. It was okay though. Watch it again, do the same thing. And you see how the pressure actually went down below what our idle pressure was. Zach, do that so Dana can see it. One more time. Good. You see how that pressure actually dropped right there? Yeah. And that's what I was telling you guys, that it dropping at that moment's not a problem, because that's a decel event where our vacuum's very high in the manifold. There's times it's okay to drop, and that would be during a decel. You saw during our XL, it increased. During the decel, it decreased, and then back to idle. And that's why when I do this test, I always tell you guys, take the vacuum hose off to do it, because it's a much more stable picture, and you don't have to interpret the gauge moving around and when and where, and is that normal, is that not normal. You leave the vacuum hose off and do the test, pressure shouldn't drop on a snap. Vacuum hose attached, you have to interpret what you're looking at. Make sure that it doesn't drop on XL. We don't care about the decel. So watch it one more time on the XL. It's actually going up on the XL because we're losing vacuum. And then on the decel, vacuum's even higher than idle, and then it drops. Completely normal numbers we have now. Let's shut this car off and let's listen to how it cranks up here after a few. And go ahead, start it back up. See how fast that pressure came up too? It's night and day different. Now we could drain this out and see how fast it comes up, but I don't have a container to do that. All right, shut that off and then turn the key back on for me. All right, the final thing I want to show you guys for this car is we're going to redo our RPM and our current for this fuel pump at the fuse box, and we'll compare that to what we had before. All right, so we are going to redo this amperage test, and just to use the same tool. And I know from some of the comments, I know there's other ways to do this. I just have one of these and it's cool, so I'm using it. And we had, which one of the relay adapters? I believe it was the smaller one, right? Yeah. Okay. And I believe it was this top relay too, right? Yeah. So we used a trusty pocket screwdriver to help us. Handy dandy. Everybody has to have one of these. I don't know if, is that camera showing on that? This one actually has 5 pins. Actually, that's a 2-inch screen, so remember that. It'll show up a lot better. As long as it's in there, we're good. Okay. This 5-pin, this middle pin is actually not being used. If you look in the power distribution box, there's no pin there. And what we're using is a 4-pin adapter. It's completely fine. If you know anything about 5-pin relays, that is the normally closed contact, which we typically don't use anyway. So just a little piece of info there. And this is actually coordinated that you can't get it backwards. Now, if you think about being able to plug this in backwards, if you're going to energize it with this tool, you're going to cook the engine computer. And that was one of the reasons I like the tool. And I had some people commenting about, hey, use a jumper wire. I'm fine with a jumper wire here. The problem with a jumper wire, if you're not extremely careful and you don't jump exactly pins 30 and 87 and realize when you're looking at it this way that when you turn it around, it flips where you're at. it is very easy to go in here with a jumper wire and jump the wrong pins, turn the key on, and you just cook the computer driver immediately. So I know there's other ways to do it. They actually make some tools too that are pretty neat, that you can plug in a adapter and you plug the relay into that, and then the adapter has pins that come out that you can jump the relay that way. Those are cool, but look how tight this box is. In this situation, we have a set of those actually in the tool room. In this situation, you're not going to be able to use that tool. It's not going to fit. So for what we're doing here, this was the ideal tool. And turning our pump on, our gauge is in that screen still too. Can you see the gauge?
Yeah.
All right, so we flip that the button, you see the fuel pump is running. Very easy to see it this time. Now what I need to do is get my Vantage Pro back over here, set that back up. Okay, so what I'm doing then, turning the fuel pump on, clipping my amp probe, 20 amp scale, zero it on my wires, and that is the load side of the pump that we're jumping at the relay box. And I'll get you guys all focused on the Vantage Pro here in a second. What's that?
What's that noise?
That noise would be fuel running through the fuel rail. So good question. We're actually pumping it in on the pressure line, and right here it's going through the rail, and what you're hearing is the regulator opening and it's running back on the return line.
Okay.
The reason you didn't hear that before is the regulator was never opening. So you couldn't hear it. It was just a static pumping fuel into the rail, no fuel being bled on the return line. So good question. I'm going to just go to my lab scope, hit yes. I'm going to go low amps 20. If you guys remember, our old pump was about 24 milliseconds for one rotation, and our amperage is definitely higher. So we have about 8 amps of current flow now, where we had 2.5 before.
Okay.
And it's going to be tough to see unique characteristics and that in this pump. It's spinning way faster too, and that was actually too fast of a time base. Move this down. It's going to be tough to see unique characteristics in a brand new fuel pump. So remember, this is an 8-bar pump, and the only reason we know that is because it's a GM. And really, you're just going to have to take my word on that GM uses 8-bar fuel pumps. Is my arm blocking? Am I good in the?
Yeah, you're good.
Okay. I'm just moving this down so we can see it. You see we're hovering above and below around 8 amps of current. So there's actually 6.8 as a minimum, 9 as a maximum. I'm not sure that's exactly dropping to 6.8 because it could have caught the first turn on. So let's refresh that. That's this button. And we'll see a min-max for sure here. Yeah, 6.8 to 8.9 amps. A lot different. And we'll get a RPM measurement by freezing the picture. And there's actually I pulled the cursors in by accident there. First, it's okay, we'll freeze that picture. And then what we'll do is place our cursors 8 apart. So starting with that one, 1, 2, 3, 4, 5, 6, 7. I need to move that over just a little bit more. Oh, darn it. I do that all the time. I hit the wrong button with this tool. That's my cursors. There's 2. Leave them on the screen, pause it. Let's try that again. Let's move this cursor to here. That's 1, 2, 3, 4, 5, 6, 7, 8, and then back to 1 would be right there, right? So 1, 2, 3, 4, 5, 6, 7, 8, 1. We have one rotation that is occurring at 13 milliseconds now. We do our math with 13 milliseconds. You guys have your phone on you? Can you do that for me? Do 60,000 divided by 13.2. It's gonna be about 5.2. Yeah, 13.2. So it's 4,545 RPM this pump's running at right now, as compared to 2,500 RPM.
Yeah.
Just showing a before and after. Not that the RPM measurement is necessary here, but a drastic difference in both RPM and amperage. no question about it. We made the right call. Thank you very much, all of you, for helping. This was a great one. My future classes, thank you too. So of course we're not done yet. We never are. I'm always like, one more thing, one more thing, one more thing. I figured, why not revisit this O2 wide open throttle test that we did. It was one of the first things we did in the classroom, if you guys remember. We used this as a guide to say, hey, we have a fuel issue, we have a fuel delivery problem. We did. And so I believe I pulled up the same data PIDs. Let's give you a perspective here. This is TPS, top left, that's percentage. Engine RPM, there's my O2 upstream, and then looking at mass airflow, grams per second, or I'm sorry, frequency. So go ahead and snap that for me. Okay, and I want you to do that again.
It's going up.
Yeah, and it's tough to see it, but let's see if we can zoom in and look at these frames. Let's do that one first. We'll do this snap. Here's my TPS, so about 7. Again, my cursors I can't really show you too well. You know what? We could try it this time. Let me redo this one more time. We'll stop collecting data, reset the frames, and as soon as the frames reset, hit that for me now. Hit it. Do it one more time. Let me let the O2 stabilize. Hang on. Try that again. I'm just resetting the frames. I want to be able to move my cursor. Okay, snap it. That was probably a good one. Let's pause that, and hopefully it'll let me see that cursor still. Snap on, pay attention, fix this for me now. This is ridiculous. I should have control of this all the time, not just at this zoomed out level. What I want to show you guys, and I'm having difficulty moving this where I want it, during the TPS rev, if you look here, the first thing you're going to see, and I don't know if I made this clear in the last part, but of course the TPS is going to be, the reaction of the TPS is going to be first. So before you see anything taking place here, before the RPM is rising, you can see the TPS signal increase first. That would make sense. The TPS is your input, everything's reactionary after that. So your initial step in of that, it's not uncommon to get a first initial drop in the O2, and I did mention that. As this RPM starts to climb and your mass airflow frequency is climbing, no, that's still lean, isn't it? What the heck? I want that to be rich during that event, unless I'm missing it, and that is my rich event right there. It is. I'm just off a frame.
Okay.
So as we rev this, see, I really need to zoom, hang on. This is frustrating. Okay, let's do this again. Let this fill up a little bit. I can't use these cursors. Okay, give me a wide open throttle snap. And do it again. Hold your RPMs up for me to at like 2 grand. Let's get this O2 warm and get the reaction of it good. All right, let it idle. What we're really having trouble with on this car with this test is this rev limiter that's on it. If we're hitting this rev limiter, it's going to cut the injection pulse and I'm going to have an issue. So, and the thing is, we can't hold it up high enough for long enough period of time to really get a good picture of this. Let's try it again. Give me a wide open throttle snap. And I heard the rev limiter right there, but if you watch this, just leave it live. You see when this is climbing, O2 is rich right here. Of course, right after that, it's not. You know, right where you're letting off or right at the end of that, maybe before he let off, because this thing has that rev limiter. I think we could probably use this capture. At 295, maybe 297, I'm starting to climb in my RPM. My mass airflow signal is climbing. There's 295 right here. And then what do you see with that O2 signal right there during that? Yes, it is. 295. There's 295 MAF signal climbing. What do we notice with the O2? O2 is now going rich as opposed to before when that O2 was dropping lean. And so maybe you guys maybe understand the test a little bit more. This is what we want to see. This is good fuel delivery. This test is tough to do sometimes with the scan tool because the reaction of the scan tool and update there, and then combined with a rev limiter and how short of a period of time we can actually hold it to wide open makes this test difficult. It was valuable to us before. We can see the after result, so I just wanted to show that.